So, what are we doing today? Well, we're going to be working with the intercept form of the parabola, which is y is equal to a, x minus r, x minus s. And we're going to understand how this relates to the axis of symmetry. Now, once we do that, we're also going to find out things like the vertex, and then we're also going to find out how the a value can be calculated given the fact that we know what the x-intercepts are, and we know what an extra point, and we know an extra point. How do we do that? And so now ask yourself, how do we know we understand what we're doing? And from the intercept form, as you see above highlighted, you're going to be able to find the vertex of the parabola and the axis of symmetry. And from that axis of symmetry and intercept form of the parabola, basically you're going to be able to determine the equation of the parabola given the x-intercepts and a point that's not on the x-intercept. So just like what we did in the previous section, so take a look at section 3.3, question example number 2 of the last video. Second last video. So what we're going to be studying is this thing called the quadratics relations in intercept form. This is the object that we're going to look at, and this object is near the CNE grounds. It's actually near Lakeshore, and it's an actual arch that that they made for the Canadian National Exhibition in downtown Toronto. Now, the arch is approximately 20 meters high from the ground to the very top of the arch where the vertex is, and its width is approximately 22 meters. In this section that we're going to actually take the time to model the arch using this formula. Y is equal to a, x minus r, x minus s. This is a third form of the parabola that we're going to study in this unit, and then we're going to use mathematics to kind of build it up, and then we're going to do some really cool mathematics with all the 3 different graphs later on in the course. So we're going to start with a warm-up. So it says, given the equation y is equal to 3x minus 5 squared plus 2, determine the value of y when x is equal to 9. And pause the video. I'd like you to make sure that you do this on your own and then see if your solution looks like mine. So our solution should look something like this. So the key idea here is when we want to find our y value, we have to substitute. We substitute this into our equation, and our equation is y is equal to 3. Well, we substitute our 9 value minus 5 squared plus 2. And that tells us that y is equal to 3 times 4 squared plus 2. And y is equal to, well, 4 squared is 16. So we have 3 times 16 plus 2, which is 3 times 16 is 48 plus 2. So y is 48 plus 2, and y ends up being 50. So to finish this problem, you would say, so the value of y is 4 is 50, and you'd say when x is equal to 9. So that could kind of give us the idea of how we would find a point, right? Now, if I say something like that, I could also ask you, tell me what the point is. So you'd say the point is, and you just say xy equals 950, and you're done. Now let's move on to today's lesson. So after you have punched in that information into Desmos, you're going to get the following numbers for our submitted values. And you'll notice that the numbers decrease until we get to x is -1, and then they start increasing again. Now, your job is to basically, you're eventually going to graph these points, but first things we're going to do is we're going to do the first and the second differences to verify that this is either linear or quadratic. So let's do that right away. So I'll do the first part. 18 minus 0 equals 18. And then always top minus bottom. Go through the work, pause the video, and see if you come up with the same answers as I do. So we take a look at the first differences, and our first differences are not the same. So now we're going to check the second differences. I'll do that in blue. Pause the video and check your answers against mine. And doing all of these calculations, you're going to end up finding that all of the second differences are the same. So therefore, this is quadratic. So here's what I need you to do. So we said it's quadratic. So here's my question. Do you know how to graph this? Remember that this portion of our graph is our x and this portion is our y. So take a moment and plot the points for your graph. Now, what I'd like you to do is I'd like you to basically take those points and I want you to graph them on this beautiful graph that I've given you. I've done them deliberately, and I've graphed the base image of y equals x squared to see what this thing looks like. Take a moment, draw the points, and we'll see what our answer looks like. And now when plotting the points, you're going to have these basic points that kind of look nicely like a parabola. Now just connect the dots. And we have something that looks a little like this. Okay? Now let's go and answer what the X-intercepts are. So what you should have realized when you graphed this is that the X-intercepts were here and here. And they were actually x equals -3 and x equals +5 for our X-intercepts. Now, it says here, how do they relate to the equation? If you look at the original equation was this. Y is equal to 2x plus 3, x minus 5. And what you'll notice is that for, say, the value 5, its opposite inside its bracket, inside the bracket, is -5. And the same can be said for x equaling -3. Its opposite in the bracket is x is +3. inside the bracket. We'll talk about that later. Now, when we want to, now we got to go and figure out what the coordinates of the vertex is. So let's go and do that right now. Okay. So if we move down here and we look at the vertex, this part here is our vertex. And we found our vertex is exactly 1, -32. And that's what we'll write here for our answer. So our vertex here is, 1, -32. And how could you use the X-intercepts to find the vertex? Well, let's go and look at our original graph, and we'll take a look at some interesting facts. I'm going to be using a very thick marker here. I'm going to highlight this in green. So the distance between here and here is, well, 5 plus 3 is 8. So the distance there is 8. Now, because it's 8, we might be able to use that to our advantage. So let's go back down to the vertex of our parabola. You remember that with a parabola, the axis of symmetry is what allows us to graph our line very nicely. But what's even better is the fact that we can take that line and split that parabola in two. And when we split the parabola in two, this allows for some rather interesting happenstances. So if you look between here and here, and here and here, that is the same distance along the x-axis. So we can use that to our advantage, right? It says, how could you use the x-intercepts to find the vertex by hand? So how to do that? Well, here's the distance. The distance here, oh my goodness. To find the axis of symmetry is exactly halfway between those 2 points, those 2 x-intercepts. So the axis of symmetry, if you think about it, is you take 5 and you add -3, and then you divide by 2. And what do you get? You get 1. That is our axis of symmetry. And you know that the axis of symmetry can be used to find the equation of the vertex by actually taking that x value and finding the y value. So now let's summarize what we should have learned when doing our little investigation for today. So it says, summarize how to find the vertex from this equation. All right, so here is how we're doing this. Your equation is based on a thing we call the roots of the parabola. So if you think about it, this is what our parabola looked like. We crossed the x-axis here and here. So what we want is we want to say that this is where the graph is rooted. Okay, 1, we find the roots. And the roots are whatever's in the bracket. Here's what you do. You say the roots are x is equal to r for this one, and x is equal to s for the other one. And it's always opposite of what you see in the brackets. And you'll notice I'm writing this in very big pen here because I want you to see it on the screen and write that down. 1, you find the roots. 2, we find the axis of symmetry. We find the AOS, and we do that by adding the roots and dividing by 2. So you'll go x is equal to the r plus the s and divide by 2. So you take those two things, you add them together and divide by 2. And then, just like before, when we wanted to find the y value of our vertex, we substituted sub x into our equation. In this case, it's y is equal to a, x minus r, x minus s, to find our y value for our vertex, and then you can state the vertex. And that's what we do for our vertex in order to find the vertex when we have our parabola that crosses at 2 points on our graph. So let's talk about that again. So we graph our values. In order to find our points where we cross the x-axis for our parabola, we look at these things here. We look at what's in the brackets. The roots of our brackets, for this parabola are x is 5 and x is negative 3. Here is where we find it here, and here is where we find it here. So when we're looking at this, we find this matches with this thing, and this matches with this bracket here. It's just the opposite of what you see in that bracket. Later on, I'll explain it to you when we're doing a thing called factoring, and you'll kind of make sense of how this works. Essentially, when you find the roots, you're actually finding what values make our graph hit the x-axis, and that happens when y equals 0. So when we get our roots, we take our roots and then we average them by adding them together. So we add 5 and negative 3, add them together, divide by 2, get a value. That's our axis of symmetry. Then in order to find the vertex, we need to plug our value for our axis of symmetry into our original equation. Y is equal to a x minus r, x minus s, and then you just state what the vertex is in the form h and k. Like how we did before, okay? All right. So pause this video, make sure you get all this down. If not, go back and watch the video again, and then you can take a look at the example problems next.